Okay, my friends, so now you have in Sheets gotten this equation for the predicted value gotten after a certain number of trades. I wanted to kind of break it down with you to make sure that in case you're dry heaving, we can make you feel better. So the output variable, or the vertical variable, is value gotten. The points on your graph are the actual data points from the article. The smooth exponential curve going through it is the prediction. You'll notice that it doesn't often catch the points. It misses them, either up or down. That's a function of best fitting lines, or in this case, best fitting curves. They don't do a perfect job of catching every single point because they can't. The points are somewhat scattered. They do a good job of averaging them over time. So that's this equation. This equation is what you're seeing in that smooth curve. Now what I want to do is I want to write it in such a way that doesn't look so terrible, and then I'm going to have you put it into your Google Sheet and drag it down and see how it behaves. The first thing I want to do is I want to write it so that it's not all on one line like this, and I want to explain that thing to you. The 99.8 is literally just that. I was actually really hoping that it was going to be 100. But 99.8, it's just about 100. All that is, my awesome friends, is it's a multiplier. That, of all the math that's going on in this, that happens last. And for some reason, the scale needs to be bumped up by a factor of about 100. So that's what that is. I don't want you to worry about that. That's not important at all. This E right here, that's a very, very special mathematical constant. Now there's probably at least one mathematical constant you're used to hearing about, which is pi, which is the ratio of a circle's circumference to its diameter. E is another one. You probably have never heard of it before, and that's totally fine. It's called E for a guy named Leonhard Euler, who I believe was the first one to study it. And it's got a mathematical value. Pi has a value of 3.1415, blah, 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 blah. E actually has a value of about 2.718281828, and it keeps going. That's not important for you to know. You don't have to know that. What's important for you to know is this over here. Now, one of the gripes I have with the way Sheets writes this out is there should be parentheses around this, because this entire thing is the exponent on E. This little caret means exponent. So there should be parentheses around this. Why there are not is it's an issue of contention for me with Sheets. If you're watching, fix it. So anyway, it's basically this entire number is the exponent on E. I don't want you to fixate on that E. What I really want you to fixate is on this. That number, very importantly, tells you that each successive trade that Demi makes, the value she gets out is about 19.2% more than the value of the thing she had going in. So she's bumping up by 19.2% on average each trade. That's what that 19.2% means. Isn't that rad? It's totally cool. The X, this X right here, is simply the trade number. It's simply the trade number. That's all that is. That's all that is, my dear friends. So X is the trade number, and the 19.2%, or the 0.192, which is the same as 19.2%, is effectively the average percent increase she gets on each trade number. Don't sweat the small stuff here. Don't sweat the E. The E is just how every computational program that best fits exponential equations, they always use base E. You can rewrite this using any base number that you want, but that's not what this class is about. Also, the 99.8, why this is out here, it's simply what's called a stretch factor. Without it, the numbers would be 100 times less than they should be. And again, don't focus on where that number or this number comes from. That's what the program is doing. It's doing the best fit models. All you've got to do is be able to, A, know what this part of it means, and B, we're going to use it in the spreadsheet next. We're going to code a little bit, and we're going to take a look at what the future trades might look like, assuming that they maintain this percentage. Let's take a look. Okay, my friends. So you're probably this far. Maybe your graph isn't quite stretched out like mine is. It might be somewhere else on your
on your spreadsheet, but it's totally fine no matter where it is. As a matter of fact, I am going to shrink it down a little bit because I'm going to utilize this column E right here. I want to show you how to put this equation, the trend curve equation. I want to show you how to put that into Sheets. It's a little bit tricky because you have to know the syntax of how to get that number E in there, but no big deal. We'll do it right here. So I'm going to do a predicted value gotten. Let's move some stuff in here. As a matter of fact, if it's okay with y'all, I'm just going to go ahead and delete the value had column. We don't even need that, right? I mean, all we're graphing here is the trade number on the horizontal and the value gotten on the vertical. And then we're going to have the predicted value. Maybe I should spell predicted correct. I don't know, maybe. So there we go. All right. So now what I want us to do is get this equation right here into Sheets. So what we're going to do is we're going to type the equal sign first, and we're going to show you. I'm going to also show you why you need to have those parentheses that I mentioned in the previous video. Okay, so we're going to go 99.8. That's just that multiplier value times. Now you can't use E. Fortunately, E is a common number, but the function for it is, there it is, Euler's number. It's EXP, which stands for exponent, and it actually tells you right there, it's E raised to a power. So we're going to pick exponent. And notice how it starts with parentheses, which I absolutely love. It's I'll put a 0 there, 0.192 times. Now, remember, in Sheets, you don't want to use X. You want to use the variable you're using, and the variable we're using is way over there in column A. In this case, it's A2, and I'm going to press enter on that one. And you'll notice a couple things. First of all, I'm going to go ahead and let it autofill it down. That's totally fine. You'll notice that the first predicted value is 10 times, more than 10 times larger than the actual data point, and so is the well, not quite 10 times larger on the next one. The first few are off quite a bit, but then it starts to catch up exponentially, and I think that's just a function, just like you said back in the beginning of the exam, when you look at ratios of small numbers. Small dollar changes make large multiplicative changes, and since exponential models are based on multiplications and not additions, they kind of blow out of control there. I want to go ahead and change this to dollars just because it's easier to look at that way. There we go. You'll notice that as we get down the predicted value, we start to match better. Like when we get, what is this, MacBook for DSLR camera, the predicted value and the value that she actually got are pretty much spot on. You can also see that over here in the graph. Now, you can keep scrolling down, and if you do, you'll eventually see that the predicted tiny house value is about $8,300, where it was actually quoted at $9,500. And that's because as the trades go on, they begin to widen around the exponential model, and that's totally fine. What you're going to be doing with this exponential model later on in the exam is extending the trades past 23 and seeing what would happen. Real quick, though, what I want to do for you here, I want you to take a look at what would happen if we didn't have the parentheses around times A2. So that's what it would look like if we didn't have the parentheses. Notice it doesn't change a thing for the first one. But then as we drag it down, look what happens. Much different. Absolutely much different. If you only raise the E to the 0.192. And I'm going to leave this up as an extra credit question for you if you choose to answer it. And you may have to play with this a little bit. I want to know if I forget the parentheses, or if I forget to include the variable in the parentheses, what kind of model is this that you see right here? I'm gonna leave that as an extra credit for you at the end of the problem. You'll see that. To answer the rest of the problem, you definitely don't want to forget them. You want them in there, and you want to make sure that you continue that all the way down, because you want to have the entire thing in that exponent, including the number of trades. Okay, I think you've got enough to get the rest of the problem done now.